Khan Academy, but it's pretty much just a skill type of thing. But if you're having problems with just skill work, they have really good videos, and it's free. So if you're like today's lesson, we're going to do the physics stuff. Maybe you want to go back and get another perspective. Also, there's stuff in Sophia, but I haven't had a chance. And Sophia's a Minnesota-based website, and I haven't had a chance to go through and watch the videos. Unfortunately, sometimes they're wrong. I did a demo of one, hadn't looked at any videos, the one I happened to pick, they were wrong. But anyway, it says find an equation of the line tangent to the following curves, then use a graphing utility to plot the curve in the tangent line. Why don't they do that first? We're going to graph first, because it makes more sense. Well, we know what that looks like, don't we? The answer should be yes. Because what's the parent function? Sine of x. Okay. Then I'm going to do 2 times the sine of x. What does that do? Stretches it, right? Doesn't change the period, but changes the height. I just think it's easier to see. Okay, question? Okay. And then what's the 1 going to do? Shift it up 1. So that should be, that's going to be up at 1. That should be at 0. There. Well, still not right, but it's close enough. Okay, pi over 6, this is 90 degrees, so it's 30 degrees. I really want the equation of that tangent line. That's what it's asking. Okay, so if it asks you for equation of a tangent line, I start with the equation of a line. What's the equation of a line, Brian? Always use point slope. I know it's not what's in the back. Y minus what? Right. So when I know that, then I know I have to look for the x-coordinate, the y-coordinate, and the slope. Now, if this were free response, to get the y-coordinate is no big deal. You do not have to evaluate it, but we will because we can. So what is, and I'm going to actually call it y of pi over 6, because that's kind of how our calculator looks. It's equal to 1 plus 2 times the sine of pi over 6. We have not done much with the trig. Oh, you're right. Is this 3.5? Thank you. I'm just putting it in here, unless I copied that wrong. I'm trying to find it. No, I'm not doing that. I'm trying to find the y-coordinate, because it's pi over 6, and it's the y of pi over 6, or f of pi over 6. Doesn't matter. It's the same thing. Okay, do you guys know what pi over 6, how many degrees that is? 30. Do you know what the sine of 30 is? If you don't know, you draw your little triangle, and you prefer degrees, as do I. Then there's 60. This is 2. This is always half the hypotenuse, and that's square root of 3. I would write those on your exam, on the exam day, and so now you know what the sine of 30 degrees is. Okay. In a donut hole. Okay, so now on the exam, if it's free response, I would not evaluate that. I would write it in 1 plus 2 sine pi over 6. But because we're so smart, we can do this. What's the sine of pi over 6? It's 1/2. So what's the y value there? It's 1 plus 1. So it's 2, right? Okay, so my ordered pair is pi over 6, comma, 2. So now I've got y minus 2 equals my slope, and it's x minus pi over 6. I'm almost done. I just need to find the slope. How do we find the slope? How do you find the slope? We're not going to use a calculator. Take the derivative, because the slope is the derivative. So m is equal to the derivative with respect to x of the y, which is the derivative. I'm going to slide this one moment. Of 1 plus 2 sine of x. This one was not too tough. There we go. You just take the derivative. That's all. It's all a slope is. Now notice I call this dy dx, but notice how I wrote it. I wrote the derivative of x of y with respect to x. Okay, Jack, what's the derivative of this? You guys need to be focused in class. I know it's hard, but you need to do it. What's the derivative of 1? 0. So it's 0 plus 2 times cosine of x. And where are we going to, now slope is always a number. Always a number. So I'm going to evaluate this at x equals pi over 6. So m is, and now if I were on the free response part of the exam, I would just do cosine of pi over 6, 2 cosine pi over 6, and use that and just not evaluate it. Because if you evaluate it wrong, Stephen, it's wrong. That's the problem. What's the cosine of pi over 6? Because I have a nice picture here. It's the adjacent over the hypotenuse, so it's not 2, square root of 3 over 2. I thought you said 2. So, okay, and then what happens to 2's? They cancel. So my answer, when I'm done, it's a multi-step problem. But that's where the thinking comes in. There it is. Yes, you could. If you check your answers, but you guys need to practice. If you check your answers in the back of the book, they actually will have that. I don't know what form it's going to be in, but they'll have it simplified or evaluated. On the multiple choice part of the exam, you do have to be able to do it. So my recommendation is in class, you need to practice finding the cosine and sine of those angles. Okay, you guys in the back? Okay. Ready? Of alpha, you mean? Yeah, you just leave it. But that won't happen. When you start, you guys, I have all those AP questions, multiple choice and free response. They are up on Schoology. Okay? So you can go and look at them and see what they look like. Wouldn't hurt you. Okay, are we ready to start the new thing? Did that answer your question? Okay. E to the x. My favorite one. Okay. First, I want to say I'm using this more for scratch paper. Okay? Because I redesigned the lesson this morning. Okay, girls? So there's things we're not going to do. We're not going to do this example 1 of enlarging circles. We could, but we're not. It's not in our book. So we're not going to do that. On the next page, we will do that, but I have it cleaned up. Page 3, the example of this particle here, we're going to do that tomorrow. It's not my favorite lesson. I'll tell you that right now. And then the last one is a physics, and we'll do a homework problem. So basically, it's physics today. Now, some of you want to use your physics formulas, and they only work for constant acceleration. They do not work if the acceleration is not constant. So that's a problem. They also, despite what you might think, are more difficult. It's not that hard to do. Okay, we're going to do position. We're going to do instantaneous velocity, guys in the back, and average velocity. We need to know the difference. You need to be able to find both. When they do an average rate of change, they're going to be particular on the exam. It appears, I think one exam was like 6 times, so we have to know that. And we're going to do acceleration. We'll do a little bit with word problems. We'll do the motion along the line tomorrow, because that's the hard stuff. Here's the deal. Derivatives give rates at which things change in the world. Probably everybody in here has had strep, right? You've had a throat culture. And what do? They look at the change in the bacteria as time changes to decide if you're sick. That's a derivative. So what they call a rate, and I'll say this over and over again because it took a while for it to sink into me at least, a rate of change. And a rate is a ratio or a fraction. So I'm going to ratio how the population changes as time changes. If the bacteria grows, then you know you have strep and you have to get an antibiotic. So that's just one real life example. We do it all the time. You're talking about your mileage. Miles per gallon. It's a rate of change. Rarely do we ever collect data about a function. We collect data about how things change in the world, and then we try to model that with a function. So population growth is really kind of nice. We use PERT. Remember PERT? P is equal to the initial population e to the RT. That's exponential growth. It looks like this. Now, I have a little problem with it. My population grows like that. What's going to happen? Too many people. It's already happening in some places. I had too many cats on my farm once. I had 22 cats. No, it's a farm. They were outside cats. So they had babies, but half of them died because of distemper, because nature takes its course. There's just not enough space. Well, I have plenty of space, but there's just too many cats. No, nature did. They all got distemper. I saved one out of a litter is all I could save. And I had him until last spring. Okay, but that's what derivatives do. That's all it is. Now, I want to look at instantaneous rate of change and an average rate of change. Let's do both together. Then we'll get into the physics. Here's my function. No, it's not. Sorry, I meant to do this. We've done this. This is old. Here's my function, and this is my average rate of change. Okay, do you remember how to find your average rate of change? It's just your slope. So I'm going to call that x. Sorry, it's at the origin. Didn't mean to put it there, but then this distance is h. Do you remember this? Then this is x plus h. And you just find the slope between these 2 points. So this ordered pair is x comma f of x. This is x plus h comma f of x plus h, because I don't know what the function is. And how do you find the slope? Do you remember that, Jack? Do you remember that? What is the slope for my average rate of change? It's the change in y over the change in x. So it's f of x plus h minus f of x all over x plus h minus x, or just h. That's your average rate of change. You have to read the problems carefully, because they might talk about average speed. They might want to talk about average acceleration. You have to read the problem carefully, because there are a couple ways to do averages, but right now it's just slope of the secant line. Well, what about the instantaneous rate of change? I want the instantaneous rate of change at x, so I'm looking for the slope of the tangent line. So the instantaneous one is equal to, what's the difference here? It's f of x plus h is still the same, minus f of x all over h. But what are we going to do with h? Make it go to what? 0. Because I want to find the slope of this line at a single point. I can't do it. Slope makes me have 2 points, so I get 2 points really close together, infinitely close together. I will find a limiting value. It's getting close to a certain value. That's the derivative. So that's f prime of x. Okay, so instantaneous is the derivative. Average is just the slope. So let's say that. This is just slope, and this is derivative. Does that help? I saw some light bulbs go on, actually. I heard some. Oh, and that's what's going to happen in this class. You'll be able to do some things, and then you're going to look back and go, oh, that really wasn't that hard. It's just going to take time. And everybody works at a different rate. That's all. Okay, well, we're going to extend this into physics now. But I think this is kind of cool. And I'm not really going to work off that sheet too much. Okay, I'm going to do a position time graph. And we're going to go to Chicago. If you live on the East Coast, you find everything's close. If you live in the Midwest, you got to go a long ways to get any place. So Chicago, we're going to start here. Here's our time. And you're going to start off, you're going to go constant speed for a while, and then you're probably going to, what? Stop. Hopefully you're not going to go backwards. Yeah, and go for constant speed, and then you might end up over here someplace. This is Chicago. It's just to make life easy, we're going to say it's 400 miles. And we're going to say it took us 8 hours to get there. Any place on that sheet, especially the circle thing is all gone. We're not doing the circle stuff. Or you can get your own piece of paper. I just gave it since, yeah, the back is, well, the back we're going to do too. Okay, what is your average velocity? Well, it's the change in your position over your change in your time. Now, forget calculus. What's your average speed? You went 400 miles in 8 hours. Yeah, sometimes we let the math get in our way. We know we average 50 miles per hour. Does that mean I drove 50 miles per hour? Nope. And you can talk about, as you're going down this path, you know, here you're going at a constant speed for quite some time, but then you're going to slow down and you're going to stop. Now, hopefully that's going to help a little bit with problem 8 out of the homework, because you're going to analyze a problem that looks like this. Read the example. It's hard reading. It's not easy. Okay, so I want my average velocity. That's this line right here. Whoops. I'll fix that, I think. Yeah, it's miles per hour. Okay, it's pretty close. And then, but I could talk about my instantaneous speed, which is clearly larger than the 50 miles per hour. 55 is it. That's what the speed limit is. So maybe I'm going 55. And so that's what you see on your speedometer. That's your instantaneous. Do you see the difference between average rate of change and instantaneous? Okay. So I'm going to get into the physics. Do you remember, now how many of you had physics or in physics? Okay. Do you remember the falling body problem? Or you have a constant acceleration. Some of you are not going to like the fact that math books use English units. I don't know why they do, but they do. So, do you know what the formula is? We will give this to you. You don't have to know it. Your position is equal to 1/2 the acceleration times the square of the time plus the initial velocity times the time plus your initial height. Now, I use S for position. Because I don't like D for distance. They always use S in physics. Okay? That is a falling body problem with a constant acceleration. You should probably write it down. I don't think it's in your packet. Okay. How do you find your velocity? Now, does that look familiar, physics people? Yeah. They use D? Oh, okay. Thank you. I didn't know that. I don't like D because you know what we have to do now? We need to find the velocity. How do you find your velocity? Well, your average velocity is change in S over change in time. What's your instantaneous velocity? It's the what? Derivative, which is ds over dt. I could use x's. It doesn't matter, the dummy variables. But if I change time, I change my position. It's always a comparison of two changes. It's a rate of change. Okay, Stephen? Yeah. Okay, what's the derivative here? It's ds dt. Can we take the derivative of that? Now, a is a constant. It's either negative 9.8 or negative 32. But it's 1/2 a, and now we'll do the derivative of t squared, which is what? I need the derivative of this guy, 2t. Plus, now v0 is your initial velocity, so what's the derivative of a number times t? Lexi? What's the derivative of this one? Yeah, just that number, v0. And what is, that's just your initial height. What's the slope of your initial height? Horizontal. 0. If we clean that up, we get v equals, the 1/2 goes, I get acceleration times time plus the initial velocity. Question? Yeah. Does that look familiar? Should look like a physics equation. And how do you find your acceleration then? Because what is acceleration? Now I'm assuming, I have to make an assumption that not everybody's had physics, because that's true. What's the definition of acceleration? It's the change in your velocity over your change in time. Now this is average. How do you find the acceleration at an instant? How about instantaneous? It's just what? It's the derivative of the velocity. It's the derivative of velocity with respect to time. Or it's the second derivative of the position. Remember that second derivative? Hey, Stephen, what's my acceleration here? Acceleration is dv dt. So if I took the derivative of that, what is it? It's just what? What's the derivative of at? A. What's the derivative of the initial speed? 0. Now, this is a constant acceleration. I might not have that. That's the deal. Well, what if I gave you s equals t cubed minus t? Then what's your velocity? ds dt, which is equal to what? 3t minus 1. Now what's your acceleration? It did turn out that a was a constant because it was a constant acceleration. Is this a constant acceleration? What's the derivative of this guy? 6t. What's the derivative of minus 1? 0. Is that a constant acceleration? Not constant. Because it's 6 times my time. At t equals 0, my acceleration is 0. At 1 second, my acceleration is 6. At 2 seconds, my acceleration is 12. It may be a constant growth, but the acceleration is not constant. No, and we'll do a problem.
What's the dsdt?
The change in your position divided by the change in your time. Instantaneous.
Like, why did you write it for that?
Because that's what velocity is. So velocity is, this is the instantaneous, yes. Pardon? Well, I made this equation up. When you do the physics problems, they're going to be constant accelerations unless they tell you something otherwise. No. What's the slope of that? -1. Okay, so let's look at a little physics, because we have to have this. This is about particles speeding up or slowing down. Okay? And you want to use your intuition. You want to think about this. I'm going to take this pen. Well, first let's get these vectors in here. Velocity is a vector. I write it this way. I don't know how you guys write vectors in physics. That's the way I've always done it. This is the velocity vector. Okay, what does that mean? Ann, do you know what that means? A vector? You're not in physics? Okay, a vector has both direction and magnitude. So it matters what direction I go. And some of these things are in the handout. I'm just kind of going without it. Acceleration is also a vector. Okay, so here's the deal. We have all accepted this. If the velocity is positive, then you're either going to the right or you're going up. By convention. Jack, question? Okay, what if the velocity is negative? Then you're going to be going left or down. Not everybody knows this. So I have to assume all of you have no physics. And the same with the acceleration. Acceleration is going to be positive or negative. It doesn't really have a meaning. Deceleration, if you go to physics, ask your physics teacher what deceleration means. If I get upset, say there is no such thing. Acceleration is positive or acceleration is negative. And this just has to do with like directions. So if I throw an object up in the air, so here's my object. I'm going to throw it up in the air, so my velocity is positive. But what about my acceleration? We've agreed that the force is pulling us down, so acceleration is less than 0. Now, forget that it's math or physics. You know the answer to this. If I throw this pen up in the air, is it speeding up or slowing down? Slowing down. These are they're opposite signs. So if you have opposite signs for V and A, then the object is slowing down. Then, of course, you heard about the guy who decided to go faster than the speed of sound. What did he jumped out of? Yeah, how did he get there? Was it a plane? I was going to say a plane can't go there, right? There's not enough oxygen, right? Okay. So now you jump out of this balloon. What's your velocity? Right? What's acceleration? And what's happening? You're speeding up. This is going to be on the exam. It's usually question 2. What's that tell you that I already know what question it is? It's usually question 2. Not always, but often it is. So I'm going to box this. And this should make some sense to you. Yeah, that'll wake you up. So if the velocity, acceleration are different signs, then you're slowing down. If the velocity and the acceleration have the same signs, so if B is greater than 0 and A is greater than 0, you are speeding up. Okay, they've asked that for years and years and years. Expect to see it. When I know of something that's absolutely for sure, we got to make sure we get that part down, right? Okay, but you have to read the question because sometimes they're not asking that. So you really have to read the question. And then I save these. I put them out as a PDF. I put them up on Schoology in the PDF files, the Smartboard files. And you can print it out, and you can print them out in color if you want, because they're all in color. So you have all of this, although it helps, to me it helps by writing, but you have it all written there. Plus you have a video, but that's real time. Okay, what I did on your handout, because this was kind of confusing, it says the same thing, but I copied and pasted out of your book. But that's what it says. Now, one of the important things here, and if you look at motion along the line, right up at this top line, it says the displacement of the object over the time interval is the difference in the positions. I would prefer to write that as delta S, because I think this is confusing, is S of t plus delta t minus S of t. So you take your position where you begin and your position where you end and subtract them. Okay? We'll get to distance and displacement later on. I've already done this, but make that S, and that's S, and that's S. I already did all that. That's what's on the other slide. Now, how do you get your velocity? This will be a calculator question. I'm sorry, your speed. I said it wrong. Because what's going to happen is the math, the calculus, to do what you have to do with the speed is too hard to do by hand, so it will be a calculator question. Yeah, you change that to S, then it makes more sense, doesn't it? But they all do this. Because that's out of the old book, and this is out of this is out of the new book. This is out of the old book. They all did it that way. But make them just S's. And then here is the grid of what you're going to need for free fall. This is constant acceleration. Forget page 130 because I don't know what it is. Constant acceleration. Yes, because it's math book. Keep in mind, we started with metric back in the 60s, and we still haven't adopted them. But you know who reason for that is? It's the car makers. Because they already had all the machine parts tooled and everything. They didn't want to redo that. And so we've stayed with our English units. Who's the only other place that does that? Australia? This way. Thank you. It's all in here. Okay. So if you want the speed, you just take the absolute value of your velocity. That's it. Yes, we're going to do a problem. Let's do the physics problem, and then we'll do problem 9 out of the homework. 8 is like the example problem. And I thought I think they do a pretty good job, but I had to really read that example problem carefully. So I know you guys are going to have to read it carefully. And learn to read your book. In fact, I really recommend you read this section before tomorrow. Even if you, no, but tomorrow I'm going to do the particle motion. No, it'll squish on my board. Okay, let's go over here and do the physics problem. We're going to do this one tomorrow. You're not going to like those things. That's okay, if I ended up stepping on it though. Okay. I draw pictures. There's nothing given to me in this problem. You are standing on a cliff 100 feet above the ground. You throw a rock into the air with an initial velocity of 2 feet per second. Find the equation for position, assuming acceleration to gravity is negative 32 feet per second squared. You throw a rock into the air. So I like to draw a picture. So I'm standing on a cliff. How about find the velocity equation? Is that better? Okay. You're standing there. You throw a rock into the air, and it's going to go up, but it's going to do what here? Yeah, it'll go up a little bit. Relative to the height, not much, to tell you the truth. This is what, 100 feet? Now, when I do these problems, I write in what I know. So when t is equal to 0, this is before I even do the problem. When t equals 0, what's my height? It's 100, right? I know my velocity. The velocity is 2, and it's positive, so it means it's going to go up in the air. Relative to 100 feet, it's not very big, honestly. What about at the top? I don't know what the time is, but I do know something at the top. I don't know the position either. Velocity 0. So see, there are things given to me. Hey, Jack, Brian? What about at the bottom? I don't know what the time is. I don't know what the velocity is, but I do know the position is. You're on the ground. It is 0. Well, it's negative 100 if you set your coordinate system up at the top of the cliff. And you certainly may do so. It doesn't matter where you put it. It's invariant under a translation. In other words, it doesn't matter where you put the coordinate system. I'm putting mine down here because that's why I do it in math. No, we can't do air resistance. That's way too complicated. Okay, Noah? Not good. So this is a constant acceleration. So what's the formula for position? 1/2 at squared plus the initial velocity times the time plus the initial height. Is that okay? Well, that's just the generic equation. Let's put our numbers in now. So what's A? Negative 32. And the science people would be upset because I'm not putting my units in, but what's your initial velocity? 2. And your initial height is 100. Yes, it is. Okay, so my position is negative 16t squared plus 2t plus 100. And you guys know the formula for velocity, but let's just use our calculus. What's the velocity? It's the derivative of that. I mean, you won't get the same answer even if you use your physics formulas, but that doesn't always work, by the way. It only works for constant accelerations. That's the problem. So what's the derivative of this one? T, good, plus 2. That's what question A is asking. So that wasn't hard, was it? Because that's what math and physics people do. That is, B is DSDT. And then it says, what is the maximum height? Now we look at our graph, okay, guys in the back, and the maximum height, I need to know what? I have a formula here for position. I want to use that formula. What am I missing? Time. But to get the maximum height, I know that I can find the time because what's true? The velocity is 0. Okay, so V equals 0, and we just solve that equation. 0 equals negative 32t plus 2. So we subtract 2 from both sides. So negative 2 equals negative 32t, and then we divide by negative 32. And you guys are used to calculators, which is fine. But I know it's 1/16. 1/16 of a second. So it's not very long, is it? It doesn't change very much. Doesn't get up too high. Okay, so what's the height? I'm going to put it right in here for t into my position equation. So s is equal to negative 16. Now I don't have a calculator handy. Well, I kind of do, but I don't need it because arithmetic's pretty easy. Now it turned out nice numbers because the 16 will cancel with one of those, so I'm left with a negative 1/16 plus 2/16 plus 100. So that's going to be S equals 100 and 1/16. So it's not very much, is it? 1/16 of a foot, right? Yeah, you're up the 100 feet and another 16th of a foot, which is really tiny. Okay, what is the velocity of the rock when it hits the ground? Well, what's true about when the rock hits the ground? I've got it right here. S equals 0. So 0, I need to find the time to find the velocity, right? Negative 16t squared plus 2t plus 100. Now, I showed the other class how to do this on your calculator. It's kind of cool. You want to know how to do it on your calculator? Without graphing it? Okay, I am going to use a solve command. Everything that's on this calculator is in the catalog. So if you go second catalog, I want to pick up the word solve. Unfortunately, on an Inspire, I could type in solve, but on this, I can't. So it's second, and the catalog is above the 0. Now that's A. If I arrow down through that, it's going to take me 10 minutes. So this says alpha. Unfortunately, it's not quite as good as Outlook. It only does the first letter, but I'm going to put in an S, and it'll jump to the S's. There we go. Now I arrow down till I get to solve. I better not do it that fast. Alpha S. The alpha is already there. There's a lot of stuff with S. I wish it were in a drop-down menu, and there is a solver, but I don't like it as much. See, here's where you're going to learn some math. There it is. Solve. I wish you could type it in, but you can't do that either. So I want to solve this equation for 0. I could have factored it, but since I'm using the calculator, why bother? And so I'm going to type it in. It's negative 16. And I don't want to use t's because then I got to go alpha t, so I'm going to go x. It doesn't matter. Plus 2x, they're dummy variables, plus 100. This always solves for zeros. So if you want to find intersections, you're going to have to subtract. And then you have to tell it you want to solve for x. And then, how many possible answers are there if it's x squared? This is a fundamental theorem of algebra. 2. Even if they're imaginary, it still has 2 roots. So I have to tell it where to look. So if I type in 0, I want to look at 0, it'll give me one of those roots. It won't give me both. roots, solutions, zeros. Same thing. Well, that's a negative time. That doesn't make sense to me. So guess what? I gotta take another guess. Well, solver makes you do the guesses, and it's just weird how it looks. Okay, so I'm going to go second, enter, because it took me too long to find solve, but there it is. And I'm going to change this to 3. I just randomly pick a number. You could do 10. Let's do 10. We did 3 in the other class. There it is. It doesn't matter. You're looking for 2. Now, if they're really close together, then you got to make a good guess. I know how this works. Newton's law, Newton's method of finding zeros. So the t here is 2.563. Now, when you put this into your velocity equation, you have to have all those digits. It doesn't matter what. You can't do that. Okay, what's the velocity equation? Is equal to what? Negative 32t plus 2. So I want to put this in. V is equal to negative 32 times 2.563 plus 2. So how do I do that easily on my calculator? Because I can't. I don't want to type in that nasty number because I'm lazy. And I'll do it wrong. Okay, I'm going to clear that. Ooh. No, I'm not. I'm going to store it. Pardon? I can. Well, I can do. Okay, negative 32. Where's second answer? There it is. Answer. See if that works. Plus 2. Oh, that works too. And it keeps all the digits. So it's negative 80, meaning what? The velocity is negative 80 because it's going down. And what's the speed then? It's the absolute value of the velocity, so it's equal to 80 point. Always 3 places. So I really should have had 0.024. And we don't care if you truncate or you round. If you round, you better round right, though. I just say truncate. Okay? We didn't give it a very big velocity. 2 feet per second isn't very much. Okay, we have enough time to look at problem 9. Okay, we can do it. I'm here tomorrow morning. Now, this is out of 3-6, number 9. So this is a homework problem, so you understand what you're doing. If you're not doing the review questions, read them, look up at the answers. You don't have to do them, but see if you can figure it out. Now, number 8 looks just like the example problem, but number 9 looks a little different. Oh, I'm going to go to the end. Yeah, this is on page 178. Problem number 9. And I'm going to change it to S of t just right away because I don't like F of t. Okay, I'm going to write the directions down so I don't get lost. I should have made a picture of this too. I didn't even think about that. Okay, now we should know how to graph this. You guys, y equals ax squared plus bx plus c. Typical quadratic equation. Do you remember how to get the vertex? You have the ACT coming up this weekend. This may come in handy. Well, it's minus b over 2a. Otherwise, you find your x-intercepts and you average them. Find halfway. But why is it minus b over 2a? Because if you're taking a parabola either this way or you take it this way, what's true about its derivative at the vertex? It's 0. So what's y prime? What's the derivative of ax squared? 2ax. What's the derivative of this? B. And because we're at the max or min, which is chapter 4, the derivative has to be 0 there, and we're going to solve for x. So minus b equals 2ax, and I'll divide by 2a, and there it is. Now you know why it's minus b over 2a, where nobody else does. Only people who know calculus know why it's that. That's the x-coordinate for the vertex. Okay, but it's easier if you can find intercepts, and I can find intercepts here because we can factor this. So where are the intercepts there? At t equals 0 or 4. What does this look like? It looks like a parabola. It's got a constant acceleration, unfortunately. So we're going to graph it. And 0 and 4, it's going to look like this, because it's on the interval 0 to 5. Please make sure, if I don't finish this, that you go to period 2's answers and check the endpoints of those intervals, because that's important. Okay, so it says graph it. That was it, right? Oh, and where's the vertex? Well, if this is at 0 and this is at 4, where's the vertex? 2. Good. So that's 2, which is kind of nice to know. B says find the velocity. Well, you could graphically find the velocity, or we could do it with a little bit of calculus. What's the velocity? How do you find the velocity from position? It's the derivative of the position with respect to time. It's the derivative of that. What's the derivative? 2t minus 4. So when t is 0, I'm down at negative 4. Whoops. There we go. And at, what happens at 2? It's 0. And we have a slope of 2, so it does something like that. It shouldn't surprise you. What's true about the slope of the tangent line here? It's 0. What's true about these slopes? They're negative. My function should be below that. Okay, then it says find the acceleration for C. Well, what's the acceleration then? Acceleration is the derivative of the velocity with respect to time. What's the derivative of this guy? It's 2, right? So that graph is up here someplace. That's acceleration. So we now can answer part C. I hope I did everything I was supposed to. Oh no, B asks a little bit more. B asks, it says, when is the object stationary? In other words, when is it stopped at x equals, or t equals 2, right? And then it says, when is the object moving to the right? Now, I always say why first, because then I know what to do. Okay, you guys in the back? When is the object moving to the right? How do you know it's moving to the right? The velocity is what? Positive. That's your justification on your exam. B is greater than 0. Well, when is it moving to the right? It's moving to the right here, right? Is it moving to the right at 2? No, it's stopped. And it goes to 5. Is it moving to the right at 5? Yeah. So be careful with your endpoints on these intervals. I believe they're going to be picky. I haven't had to grade one like that, but I believe that they will be picky about it. It's moving to the left when the velocity is negative, which is B down here. What's that interval? Do I get to include 0? Yes, it's negative. It's tricky because it's a detail. I don't like details either. And I go to 2 because that's the part I always get wrong. Okay, that was it. C, what's the acceleration at t equals 1? A at t equals 1 is easy. It's just what? It's just 2. It's 2 everywhere. Okay? And what's the velocity at t equals 2? Velocity at 2, when we look at our graph, it's just 0 right there. What's the next one? That was C. D, what's the acceleration when the velocity is 0? No, the acceleration is always, in this case, it's always 2, but it won't necessarily be. Last, yeah. Wouldn't what be different? Oh, I didn't know. That was at v equal to 0. Sorry. What about at t equals 1? Oh, no. You're right. I did it at 0. It was what? 2t minus 4? So what's the velocity at t equals 1? Thank you for correcting me. So it's negative 2. Now, okay, you guys, what's happening in my particle? Or my object, whatever. This is positive. This is negative. It's doing what? Slowing down, because what happens at t equals 2? It has to what? Stop. It's going to stop, turn around, and go the other way. It's like going back from reverse to forward in your car. Okay, now be careful. This is not the object is speeding up. The speed is increasing. How would you do that one? Your speed is increasing. The acceleration has to be what? Positive. We don't have that formally down yet, but if you think about it, well, where is the speed increasing? Where is the acceleration positive? Everywhere on 0 to 5. But you'll have to look at your graph or your function to see. A is always positive. Speed's increasing, even though the velocity is negative here, it doesn't matter. Is the velocity getting bigger and bigger and bigger, even though it's negative? Yes. Well, I want to say the velocity is increasing. Is the speed increasing? Better come back on that one, because I don't think I'm right. See?